This matchstick is giving out 1100 joules of energy per second. But this sunburned piece has more than 260 trillion joules of energy in it. Yes, you heard it right. 260 joules in it. Everything in this universe is made up of matter and energy, and we can convert the mass of an object to make some energy and vice versa.
Now consider this, we have an object of mass 1 kg, and from that we can get more than 9 into 10 to the power 16 joules of energy. That's a 9 followed by 16 zeros. This shows us that even a little bit of mass can be converted into a huge amount of energy.
But don't take my word for it. It was the great theoretical physicist Albert Einstein who in 1905 said that the energy of a body is equal to the mass into the speed of light square. E is equal to mc square. Mass can be thought of as an indicator of how much energy there is in a body. So we can say that mass and energy are the two sides of the same coin, and we can convert mass to make some energy and vice versa. Now let's see what happens in the sun. As you know, the sun exerts some energy in the form of light and heat. This is nothing but its mass which it is losing. But this mass is very insignificant. It's just a billionth of its trillionth of its mass. So what we can understand from this is that the sun in 1905 is much heavier than the sun today, and it will be much heavier than the sun after a million years. But this is not why we are here today. There is another obscure, rather untalked reason which led to this theory. Does the mass of an object depend on its inertia? I have taken two identical toys. One of them is dancing and the other is standing still. Now, if we weigh them, we find that the dancing toy is a little heavier than the other. So did the movement of the toy change its mass? Yes, the gears in the dancing toy are moving, so they have some kinetic energy. Also, the springs in the dancing toy have some potential energy, and there's a little bit of friction between the moving parts that heat them up. That's thermal energy. This extra energy is nothing but the extra mass. But this extra mass is significantly less. We took two identical toys, so their rest mass or rest energy is the same. But we added some extra kinetic potential and heat energy in the second toy. So now the whole energy of the second toy, which is accounting for the extra energy caused by its motion, is also called its relativistic mass. The relativistic mass is basically the rest mass plus the mass caused by the extra energy. This theory was groundbreaking and led to the discovery of many more theories that we know today.